Good evening, folks. This is Ron with the Emergency Management Associates. We want to welcome everybody here that has been joining us, and anybody else that will be joining us tonight or on a delayed broadcast. Please know that you're more than welcome to be here. We're glad to have you. Good morning, good evening, good afternoon to everybody here that is joining us on the Emergency Management Associates Network. We appreciate you all joining us. I apologize for being so late. We had some technical issues, YouTube being the primary issue. Our broadcast software also was screwed up. Google screwed us up. Just a huge mess, but we're here with you tonight. I'm going to forego the Pledge of Allegiance and the United States National Anthem tonight because we're so late. I want to welcome everybody here. You guys are precious to me. You're my family, the EMA family. Everybody that joins us is part of that EMA family. I would ask everybody to make sure you're subscribed to this channel. 25% of the people that watch us show are not subscribed. Also, those that think they're subscribed, you need to go back and check your subscriptions. YouTube has also been deleting subscriptions. I've been checking. So make sure you're subscribed. When you subscribe, make sure you also click another button. There's a tiny circle there with a bell in it. A tiny circle with a bell. Make sure that you tapped on that bell. There will be a drop-down menu of 3 items. Click on the word ALL. That should get you notified when we come on the air, every time we come on the air.
Papua New Guinea, class moderate magnitude, 5.1 depth, 69.6 miles, 18 minutes ago.
Papua New Guinea with a 5.1 earthquake just 16 minutes ago. I get those messages all the doggone time, all day long, 24/7. Anyway, folks, we got a lot going on tonight. I have a lot to talk to you about, and so like I said, we're going to forego the national anthem tonight. And I'm sorry about that, because that's one of our favorite things. I first want to talk to you about a deep quake that occurred Saturday, I believe it was. Actually it was yesterday, early this morning. A 3.2 earthquake hit over in eastern Venezuela, northeastern Venezuela. It was a 3.2 earthquake, just a small quake, but look how deep it was. It was 502 kilometers deep. That is a huge, deep earthquake. Yes, it was a small quake, but it's hugely deep. Now, I'm going to go over to my software here on my computer, and I will tell you exactly how deep that earthquake is going to make us. Okay, back up, Ron. Okay, I'm going to explain to you what that deep earthquake is going to do. Okay? Usually I show you this to you, but oh, please don't tell me this. Oh, crap. What happened to it? Okay, I was looking in the wrong file. I'm sorry. I don't know how I got to that file, but it doesn't matter. We're going to go to the depth to magnitude conversion chart. This was given to me by Bella and Rebecca. Many of you know Bella and Rebecca. The depth to magnitude conversion chart shows us the strength of the quake versus the depth. In this case, 502 kilometers deep. This is going to mean we're going to get at least a 4.3 magnitude earthquake out of this 3.2. We add 1.01 to that magnitude, and we suddenly come up with a 4.3 moderate earthquake. And it's going to hit in that nearly same area. Someplace in Venezuela, Colombia, or maybe even in Brazil. It's been a long time since we've had an earthquake hit in Brazil. But folks, it does happen. It does happen. But this deep earthquake is going to propagate a larger, shallower quake. A larger, shallower quake. Okay? Let me show you another slide here. Okay, that's a close-up view of where that hit. This is a longer outward view, zoomed out view, showing you exactly where that quake hit. Okay, now let me bring this out a little further for you. Okay, look where it is. Maracaibo is just north of there. That port city up there is just north of where this earthquake hit. Okay, near San Cristobal. Okay, that's where this 3.2 hit. So we shall be expecting a moderate earthquake up in this same area very soon, probably within the next 3 days. Okay, that's what we estimated at. Now let's go over to Guatemala real quick. Saturday, Fuego volcano erupted. 22,000 foot eruption on Saturday. It was a big deal. This is when this picture depicts it as being just after it started erupting. This was a huge eruption. Now, I was not able to get the full picture of the eruption because of software issues, but this is when it first started erupting. It's quite an experience, isn't it? Okay. Another earthquake that hit during the weekend. This was a 6.8 magnitude earthquake in southern Spain. A 6.8 magnitude earthquake in southern Spain. Let me explain something else to you. Okay? This is the only earthquake app that showed this earthquake. USGS did not show it. USGS did not show this. Okay? This earthquake was 6.8. USGS did not show it. Now, it was not any more than that. Okay? It was not more than that. Let me show you something else. This is a helioplot after that quake. It was a short-lived quake. Okay? It didn't go off the paper this time. The only way it did was because of the time element where it went off the paper at the bottom. Okay? This was a 6.8 quake. Now, it also disturbed the nearby neighborhood. Look at that other line to the left of that. That's a 5.0 quake. Okay? Look at the lines after that to the right. Okay? We had some 5.0s. We had a 4.2, and then we had the secondary wave out to the right. That cone, it looks like a cone, the cone formation, okay? That's a secondary wave. And it went on for 8 hours. 8 hours. So that's quite an earthquake, a 6.8 in Spain. USGS didn't say a word about it. This is in southern Spain, okay? Oh, I'm sorry, this one here. That happened in southeastern Spain there, okay? And it could have been worse. It could have been worse. It happened in a sparsely populated area, okay? That was the good thing about this quake. It hit in a sparsely populated area, and we don't have any report of injuries or damage because of where it hit. Now, that quake was felt all over the place. But, again, we don't have any documents that show how many people felt that quake. Why? Because the main companies here, the main government agencies, not even companies, government agencies here did not report it. Okay? Go figure again. Go figure again. Anyway, this is crazy. I first heard about it from one of our compatriots, one of you, that put it up as a message to me. And I first went all over my different sources, and I said I can't find it. So they showed it to me, and that's what I'm showing you. Only one source showed that quake, and only one source reported it. So that's quite a deal as well. Now, does anybody have any questions about anything that has been happening? Okay? Raymond Roy, welcome to the show today. We appreciate you being here. We appreciate you being here. Okay, besides Venezuela, besides Deep Quake, besides Fuego Volcano, let me show you something else. We have sunspots, guys. We have sunspots. Look at all these Earth-facing sunspots. The one down to the right side here, okay, that's going to play into what happens during this coming week. And then the one in the middle there, okay, that's the other set of sunspots that are going to play havoc with the Earth. These are very active sunspots, okay, and we expect to get some kind of CME, probably a C or an M-class CME within the next 48 hours. And I will keep you updated on that, okay? When that happens, folks, we have all kinds of electrical interference here on this Earth. When we have one of those sunspots, usually before we feel it or see it here on the Earth, it happened 2 to 3 days before that. The original eruption of plasma generated from the sun and sent it out into space. The original generated plasma goes out. In that original generated plasma, there is X-ray radiation, gamma radiation, and it's sent out into space. Folks, that hits us within about 2 to 3 hours. That gamma radiation hits us within 2 to 3 hours. After that, the plasma energy takes about 2 to 3 days. Gamma, because it is light, and it travels at the speed of light. That's why it gets here quicker. The plasma radiation takes 2 to 3 days. And every time we get hit, we've been getting faster and faster plasma radiation. And when that hits, guys, what happens? First, ham radio, police, fire, paramedic radios get all screwed up. The signals get all screwed up. The ground to satellite communications gets played with, where we can't fully communicate with the satellites going up and around us, up into space. We can't fully communicate with them because the communications are all torn up because of that radiation. Plane, air-to-ground plane. Guess what? Planes have the same problem. Their communications and data get screwed up. The data and communications with the International Space Station is also played with. Everybody has a problem every time one of these CMEs light up. Then, not just that. After that plasma radiation hits the Earth, a lot of people say it heats up the core of the Earth. You're right, but it's not just the core that it heats up. It heats up the plates, the earthquake faults, heats them up. All that dirt and grime and biological material that's been holding those plates in place, guess what? It turns into grease. As it's heated up, it turns into a greasy, oily substance which allows the plates to more freely move. Just like this. Just like this. That's why we get these big earthquakes. That's exactly why we get these big earthquakes. Sweet Polly says 10 days worth of gamma. Yeah. Oh yeah. Okay? It's incredible. Raymond Roy, we're glad to see you back here. And I'm sorry you had a problem with the mod before. I don't think that's going to happen again. Anyway, guys, we appreciate you being here. I wanted to tell you about this because we have new people here. People that have never been on this channel before, or maybe it's been a long time since they've been on this channel. We're glad and welcome you back with open arms. Now, everybody, I need you to do something for me. I need you to pass this information on about this channel. When that other channel that we had been on got hacked into, we lost nearly 25,000 subscribers. And yes, it was within 18 people of being 25,000 subscribers. We lost that. We almost have 1,500 now. Okay? It's 1,494 subscribers. Please help us grow. If you have any contact or think you have any contact with anyone else that used to be on our program or had subscribed to our program, invite them here. Tell them we're back. Give them the address, YouTube address, where we're at, and invite them back. We want to grow this channel. We need to grow this channel because this is where we give you information that might save your life. We give you information about all kinds of emergencies and disasters that could save your life. Okay? So that's there. Now, I promised someone on Friday night that I would put up information about volcanoes. I still have not done that. I have not been feeling that good. I took a long nap Saturday. I didn't expect to do that. Then I had some health issues Sunday. I did our Sunday school class. Then I laid down again, got up this morning and had some other problems. I'll go into that another time. But folks, we're here for you. I will get that volcanic information to you as soon as I can. I promise you. Okay, we'll do that. Does anybody have any questions for me? Rochelle is asking, I think it was Etna blowing smoke rings. Yes, it had. It did blow smoke rings, Rochelle, and it wasn't just that. Now, let me get into, I believe it was Friday's, I think it was on Friday's program, we showed you, is that Fridays? Maybe it was Thursdays. No, it's not Thursdays either. That's weird. I thought I showed you some smoke rings that happened after the last space shot with SpaceX. I'm not seeing them. Okay, maybe I didn't show them to you. But NASA and SpaceX put a huge communications satellite into orbit. This satellite, folks, was a big deal. It was huge. One of the biggest satellites that we have ever launched. It was a communications satellite to make sure that Wi-Fi communications were going to be available to everybody anywhere, including in planes. Okay, so soon all the aircraft in the air will have Wi-Fi communications with that satellite. It's also going to help us all here on Earth, because it's not just for those kind of missions. Pretty soon, Wi-Fi will be coming from satellite communications, so all of us will be blessed with that. Okay? So, anyway, I just wanted to pass that on to you. Rochelle's asking, how often do volcanoes blow smoke rings? Not very often. It just rarely happens. It only, let me take a minute. When we have smoke rings like that, what do you think happens? There has to be a lot of pressure to break up that original smoke, doesn't it? Smoke and ash and particles come out of the volcano, right? Then after that, there is a huge explosion, an explosive eruption, and it sends material out through that smoke. That's what creates the rings. Okay? Then to top all that off, guess what happens, guys? With that spacecraft launch, okay? The launch was going very well. And it was one of the largest rocket launches that we've had too. It's what they called a Falcon Heavy. The Falcon Heavy has a normal rocket tube, okay? The first stage rocket tube. Alongside that were also two other Falcon rockets, side by side with the main rocket, okay? And just like other solid fuel rockets we've had on our rockets before, they help power that huge load of spacecraft into space, okay? They give it initial velocity to help it escape the atmosphere. And after that, the second stage takes it even higher. Okay? So having all that power on that rocket, guess what? When it went up into the atmosphere initially, then after they got to, within a minute and a half after launch, they got to a point where there's maximum dynamic pressure on the rocket, and they had to dethrottle. They had to lessen the rocket engine output, and when they did that, it had all of that smoke and all of that power, and I don't remember how many square million pounds of thrust it had at the time. I don't remember the figure, but when they relit those other engines when they had a throttle down, and relit it after that maximum dynamic pressure was over. Then they relit it, and guess what? That relit engine powered through those smoke rings, okay, and caused the rings. It powered through all that initial smoke. I was thinking of calling it something else, but smoke will do. It launched all of that energy through that smoke ring, and it caused the ring to pop up like a donut. It was a cool picture. And someplace I have that, and I will bring it up and show it to you the next few days. That's what happened. It was cool. That's cool. Anyway. I wanted to tell you that. Don Patoka says, if you're not receiving notice of when we come on the air, like Google and YouTube says they do to him, unsubscribe and then resubscribe immediately. If you unsubscribe, guess what? You're going to forget about us. Unsubscribe and then resubscribe immediately, and then click on that bell icon, and then click on the word all. Okay? That way you'll be subscribed to our channel and be notified when we come on the air. Usually. Richard Smith says 2.3 in Azores, Portugal. That's off the coast over near the Mid-Atlantic Ridge. Okay? Yes, Richard Smith says there's a 2.8 in Northern California as well. Yes. Oh yeah. It's quite a big deal. Let me show you something else that we found earlier today. It's been taken down since we captured this image. This was a 4.4 magnitude earthquake in the Cascadia subduction zone region. You see the Cascadia subduction zone that goes parallel up the coast from Northern California all the way up to Queen Charlotte Island in British Columbia. But on the Blanco fracture zone, we had a 4.4 earthquake, a moderate earthquake. Alongside it, okay, right between the Gorda Ridge and the Cascadia subduction zone, we had 2.2 earthquakes, aftershocks of that 4.4. Okay? But this is a huge region. It spans the area where the earthquakes happen. If we get a major 8.0, 9.0 Cascadia megathrust earthquake, guess what? It's going to feel like it's more than that. I'm going to bring up the map here. I want to show you the USGS map on the west coast, North America. Okay? Let me take down my banner here. Oh, come on. Oh, now we've had one over here, and guess what? It's Cascadia subduction zone time. It's just barely north of the Cascadia subduction zone, over in near Petrolia, California, 3 miles east of Petrolia, California. Okay, it's in the Cascadia subduction zone region over here on the southern end of the Cascadia subduction zone earthquake fault. Okay. This area right here where 3 earthquake faults meet, the top one is the Cascadia subduction zone. The bottom one going out to the left from there out to the west is called the Gorda Escarpment. The other earthquake fault that meets up with the other two is called the San Andreas Fault, the triple junction where all 3 faults meet. Okay? Then, if we go out here and take the Gorda Escarpment out here, we meet up with the Gorda Ridge going north here. That jagged line going north is the Gorda Ridge. Then we come out here and the Gorda Ridge meets up with the Blanco fracture zone. And from there, you see the Cascadia subduction zone continuing all the way north along the coast. We also have out here to the west the Juan de Fuca Plate, the zigzag Juan de Fuca Plate. Okay? Now, you see one other earthquake here. This is off Cape Madeiras, Oregon. Or not Madeiras, Cape Miras, M-E-A-R-S, Cape Miras, Oregon. This is a 1.7 tremor. We haven't had any earthquakes or tremors out here in quite some time, so this is a little bit of a surprise. Okay? But anyway, after we see that Juan de Fuca Plate, it also goes up north to Queen Charlotte Island, as does the Cascadia subduction zone. Now, the Cascadia earthquake that we're expecting should be an 8.0, 9.0, 10.0 quake. They fully expect it to be a 9.0. Okay? That quake is going to happen in this area here. Okay? Just west of Seattle-Tacoma area, out here in the ocean, on the Cascadia subduction zone and or the Juan de Fuca fault. Okay? Somewhere here in the north part of North America. Okay? Not on land, but out to sea. Now, when that earthquake hits, the power of that seismic energy is going to go south as well as north. Okay? The power of that energy is going to go all the way up towards Alaska. Okay? Let me bring it down. See the earthquake fault that runs from Queen Charlotte Island all the way up here to Alaska? Those people are going to also feel a portion of that energy. It's probably not going to be 8.0. It might be 6 or 7.0. But Alaska is also going to feel that seismic energy, as is the entire continent of Canada and the United States. Both countries are going to feel it coast to coast in some way or fashion. Now, when it hits, by the time it hits the East Coast, it's not going to be a 9 or 10.0. It's probably going to be felt as a 3 or 4. But folks, the entire continent is going to shake. The entire North American craton is going to shake. Okay? That's how powerful that earthquake is that we expect to have. Okay? Now, besides that, let's get back here to the west coast. That seismic energy, besides going up towards Alaska, is going to come south. It's going to come south on either or both the Cascadia subduction zone or the Juan de Fuca Plate, Juan de Fuca Fault, down here to the Blanco fracture zone, the Gorda Ridge, and the Gorda Escarpment, and that energy is going to start and it's going to go down here because of the connection with the San Andreas Fault. Okay? It's going to go all the way down south. All the way down south, probably until Mexico. It may even go further south. Now, with that said, when that earthquake hits, the further away it gets, the lesser violent it's going to be. By the time it reaches San Diego area, it might be a 5 or a 6 rather than a 8 or 9 or a 10. Yes, we could have a magnitude 10 out of that. It could happen. But the further it goes south, the lesser magnitude of quake it's going to be. The other thing you need to know. When that earthquake hits, it's going to generate a tsunami. It will be generating a tsunami. The last time it hit, the tsunami found itself all the way over here in Japan. All the way over here in Japan. And the Japanese people kept great records. Okay? The Japanese people kept great records. That's why we know the date and the time that the huge Cascadia megathrust earthquake hit. Okay? That's what's going on. Deep Quake Paul's back here in the chat. We appreciate you, brother. He says geomagnetic storm watch G2. A G2. Possible on August 1st because of a CME that's expected to impact the Earth's magnetic field. The G1 class storm is likely with a chance of escalating to a G2. Okay? That happened, I believe, on Saturday. So this is going Saturday, Sunday, and I believe this may hit us as early as tomorrow or Wednesday. Okay? Anyway, the Cascadia megathrust earthquake tsunami hit here in Japan. It was a big deal. It was a large enough tsunami to hit here in Japan. So, when that earthquake hits, it's not just going to be a tsunami that goes to Japan. Alaska may see a good deal of that tsunami wave as well. Not just one wave, but multiple waves. It could be up to 30 or 40 different waves. Each one a different size and a different amount of water involved with those waves. But the initial waves, guys, are going to be tremendous. Anywhere from 100 or 50 feet on up to 150 feet high. And those waves probably will go as far as 5 miles inland, maybe further. Why do I say that? Let me, for example, zoom in here and show you what's going on. Okay? When we get over here in the Puget Sound area, this is like 5 to 10 miles. 5 to 10 miles away. This whole area will be affected. All the rivers, all the water inlets coming from the this is called, this strait here of water from the Pacific out into the Puget Sound area is called the Strait of Juan de Fuca. All that water coming in here will be a tremendous wave. Okay? It's going to be a huge wave. The waves hitting the coast, huge waves. So all the way in here into the Puget Sound, we're going to see 50 to 150 foot waves. And it's going to go at least 5 miles inland. 5 miles inland. That's why we talk about this. Okay? Now, when we have areas, and yes, you see a lot of hills and valleys here, like this here, the water will go between these hills, and it's going to be under pressure. All that seismic energy created pressure out in the ocean. Okay? It scooped water from the shore, the shoreline, and took it out to sea. When it comes back in a tsunami wave, guys, it's going to be a bigger deal. When the water goes through a valley, or in an area of Seattle, for example, that has tall buildings, when the water goes through a narrower area, it speeds up. And it gets to be more powerful because it speeds up. And because of that, it's a scientific fact, because of that going through narrower areas, we may see more water further inland than even 5 miles. Okay? The shaking is going to be devastating all over this area, all the way through the continent. But the shaking here will be devastating, completely devastating. And what the shaking doesn't take down, the tsunami wave may. And it's going to flood out many areas, including farms and other businesses. The land is going to be completely submerged in a lot of cases. A lot of people are going to lose their lives. The best place to be is away from the shoreline. The best place to be is probably above 1,500 feet high. When the shaking stops, the people living here that are left will have their warning that 15 minutes later there's going to be a huge wave. The best thing for people to do is head east. Get away from the shoreline. Get away from the shoreline as far as possible. Okay? People are saying that anything west of the I-5 is going to be annihilated, and they're right. But if you have to go over any bridges, and I know what those roads are going to be like. The main highways are 3 and 4 lanes north and south in each direction. However, the ones going east-west are usually 2 lanes, 1 in each direction. And I know what it's going to be like. There's going to be fissures, great big holes that open up. Great big holes in the ground that open up. The roadways are going to be damaged. You're not going to be able to travel very far on those roads, if at all. The other issue is this. The bridges are going to go down. Many of those bridges have not been tested of that magnitude of an earthquake. I know for a fact. The bridges are going to go down. If you want to get away, you need to have a 4-wheel drive vehicle. A 4-wheel drive, a gator, a motorcycle, a bicycle, a 2-wheel pedal bike, 23-speed bike, but you're definitely not going to get through it with a car. Okay? This area is going to be so destroyed. The roads are going to be impassable. The bridges are going to be down. If you want to get across the Columbia River, good luck. Okay? Any river. Any river. And because the increase in water, guess what? The rivers are going to overflow their banks after the tsunami hits. That's an additional hazard. So I'm just giving you the idea of what's going to happen. Jamie Wilkie says, I am 30 minutes from Seattle, Washington. Well, that might be good if you are east of Seattle. If you are east of Seattle, that would be a good thing. But you are going to also feel these shock waves from the earthquake. It's not going to be good. Space Force Al says need to get away now. I don't think once it happens it will be possible to get out. Yeah, he's right. Nobody will really be able to escape after that earthquake hits. And like I said, once the quake hits, what the quake doesn't damage and tear apart, the water will. Now, they are building buildings. I will give it to the engineers. I will give it to the developers. They have already been building buildings and schools that withstand the quake. And they've been putting extra strength girders and everything else in these buildings to withstand the shaking. And they're building them on high ground. So the waves of the tsunami won't hurt anybody at the school. And most people that are in that area know where that school is. And it's made 5 stories high. That school is 5 stories high. And I'm sure they're building other buildings the same way. Buildings that will withstand a major event. Because the steel and girder buildings downtown Seattle weren't built to withstand that kind of shaking. Those big high-rise buildings, 20 and 30 stories in the air, sorry, they're going to waddle around, wave around just like this, and then they're going to go boop down. I've seen it. With that earthquake that happened just south of the U.S. border in Guadalupe de Victoria, Mexico, just on the south side of the United States over there in the Imperial Valley, that earthquake was over there. Okay? Just about 150 miles from San Diego. And I was in San Diego doing a disaster drill at the time. I saw the buildings do this number. I saw the buildings going back and forth like this. That was 150 miles away. Can you imagine being in Seattle, Washington, or Tacoma, or any of those other towns that have tall buildings? It's not going to be pretty. Anybody living on Vancouver Island, anybody in Vancouver, BC, or other places, even anywhere near this, it's not going to be pretty at all. I even believe in Alberta, Canada, it's not going to be too pretty either. Yes, that's further east, but I believe the chaos that this earthquake is going to cause will reach over into Idaho and Wyoming and Montana and up into Alberta, Canada as well. And then that seismic energy is going to continue east across the entire continental plate, all the way over to the East Coast. Okay? That's going to happen. That's going to happen. Kristen Cashel says, I thank God I found this channel and all of you. Every week I've been adding water, our water, food, and we have a real plan forming for emergencies of all kinds. And that's great. That makes me feel great that you are planning as well. Make sure you have a plan. Okay? Most people don't. Most people are ignoring me. Yeah, most people that I see even here in the chat are ignoring me. They don't believe it's going to happen. Now, I don't want to be somebody that's preaching doom and gloom. I don't want to be that man. I'm just telling you what's going to happen. We're trying to give you information to help you. Help you avoid being in there. Help you avoid being put in any kind of emergency situation where you're not going to survive. Meaning you're not going to have food. You're not going to have clothing. You're not going to have a roof over your head. You're not going to have anything. No water, no nothing. That's why we're here. We talk about camping gear. I encourage everybody, if they can't be in their home itself, to have a home away from home. A tent. A way to make a tent so you can survive the elements outside. Learn about tenting and camping. Make sure you have a 72-hour kit. At least a 72-hour kit. Not just food, but clothing. Make sure you have aluminum pots and pans. You can get them from outdoor stores, recreational outlet and such. Okay? Make sure you have all of that, and food as well as good sturdy shoes with good thick soles. Long sleeve shirts for everybody. That way you're not going to get sunburnt. Okay? Make sure you have a variety of hats you can wear. Make sure you have water. No one's going to survive this without water. Okay? FEMA says, oh, you have to have a gallon of water per person per day. I hope you do. I tell people to get 3 gallons of water per person per day to cook and clean with. To cook and clean with and to cook with. You're going to need it. Okay? You're going to need it. Rochelle says, I'd rather have doom and gloom instead of lollipops and rainbows. This is the real world. You're right. I'm never going to give you lollipops and roses. I'm sorry. And rainbows. I definitely won't give you a rainbow. Not today, not tomorrow. But folks, I want to give you the real facts. So you know, hey, I need to prepare. Because something is going to happen. And you're right. It is something that's going to happen. Today, USGS in all their infinite wisdom, guess what? They reported a 1.3 tremor over at Lake Kavanaugh, Washington. Woohoo! Guess what happened Saturday? They reported a tremor over here near Lake Kavanaugh, but guess what they said? It was Washington. It was a 1.7, 1.8 in Washington. They didn't say where it was or where it was near. This one says it was 4 miles west-southwest of Lake Kavanaugh, Washington. That's better than just saying, oh, it's in Washington. That's what they do. They don't want to be honest with anybody. Over here, further south, Carnation, Washington. Carnation, Washington. Is this where they sell cars, or is this where they have flowers? This is a 0.9 magnitude tremor, microquake. Southwest of there, this is Meermount, Washington, a 0.6 microquake. Microquakes and tremors usually are not felt, possibly by someone that may be very gifted, very sensitive to that kind of thing. Even minor quakes, 2.0, 2.9, are rarely felt. You're only really feeling earthquakes if it's a 3.0 and larger. 3.0, 3.9 are considered to be small quakes. That's usually when you're going to feel these quakes. Now they have started out calling these quakes something else. Okay? They're calling a 4.0 to a 4.9, which is usually a moderate quake. They're not calling them that. They're calling them light. They're wanting people to get used to earthquakes and not give a doggone, oh, that's a light quake, it's no big deal, until pictures start falling off the walls. A water main breaks, glass breakage in the windows. Why are we feeling this light quake breaking our windows? It must have been stronger. Well, guess what? I've told this story before. I was in Salt Lake City in 2014, I believe it was. And I saw on KTLA Channel 5, I tuned my television cable, made sure I had San Diego and Los Angeles channels because my kids lived there, or some of them did. I wanted to know what's going on. So I tuned into KTLA, and they were having an earthquake. One of the anchors was a friend of mine, Carlos Amezcua, and he and his broadcast partner, Carlos looked around and said, we're having an earthquake. And he and his broadcast partner got underneath their desks. That is the correct thing to do. Underneath a sturdy table or desk. And then hold on. Duck, cover, and hold on when you have an earthquake. They got out from underneath the desk when it quit shaking. That is proper. If it starts shaking violently again, duck and cover and hold on again. Hold on to the legs of the table or desk you're at. You're under. Make sure your entire body is protected. Okay? Duck, cover, and hold on. Then come back out once the quaking stops. And that's what they did. Their studio lights were swinging like crazy, like a wind was in their studio. Studio lights were swinging all over. It was a 4.5 quake. I got a call from Los Angeles, the EOC, the Emergency Operations Center. Ron, can you come to Los Angeles from Salt Lake? We will have a ticket waiting for you at the Salt Lake Airport. So I said, yes, I'll come. I packed a suitcase, ran to the airport, caught a flight to LA. I got there. Glass had been breaking, a lot of glass, all over the valley in Los Angeles. Businesses, glass breakage all over. People had to go over to the hardware stores, the home improvement centers, to buy plywood to cover their glass breakage until they could get somebody in or over there to repair their glass windows. This happened in homes as well. Water mains broke. Gas mains broke. That 4.5 was larger than what they said it was. Of course, the agency won't report accurately because they don't want anybody to know what happened. Oh, this was nothing. This was nothing. Yes, it was. It was something big. I was in LA for a week helping the city, the county, to recover from that quake. Before that, in 1994, I drove from San Diego to Northridge, California, after the 6.9, 7.1 hit in 1994. The major quake hit in the morning. Apartments with carports beneath them collapsed and pancaked on top of the cars. Buildings collapsed. Freeway overpasses collapsed. One, when a police officer was driving down the freeway on his motorcycle and the bridge collapsed in front of him and he drove right into the collapsed rubble, killing him instantly. It killed a lot of people. It injured a lot of people. I got there hours after it happened. Law enforcement agencies all over Southern California got the word that Northridge and the surrounding communities needed our help. All law enforcement days off were canceled all over Southern California, and officers were sent to Northridge as needed to go up there and assist. My partner and I parked our police car in a park in Northridge. I wish I remembered that park. It was a pretty park. We drove our vehicle over on the grass, away from trees and telephone poles and such, parked where nothing was going to fall on us. That night, we had aftershocks. Really bad aftershocks. They hit, and we bounced into the air and came back down. And because we had been sleeping, we were not familiar with what that felt like. And both my partner and I dove out of our tents. We unzipped those tents so fast and came out of those tents so fast, heads would spin. And we're going, holy crap, the ground's still shaking. The earthquake threw me up in the air, boom, boom. That was a shock. Earthquakes like that happened for weeks afterwards. Before I left San Diego in April 2000, we had 3 5.5 to 5.8 earthquakes. Okay? Incredible. 3 of them. And I can tell you about each one of them and what happened and where I was at. You don't forget those things. Why am I telling you all about that? Because, guys, everybody needs to know what happened. Your lives will be disrupted. I promise you, your lives will be disrupted when these earthquakes hit. Whether it be a 4.5 or a 6.0, 6.9, 7.2. Your lives will be disrupted. Now on top of that, let me tell you something else. I was not in California when this happened. This happened in 2019. I was in Sandy, Utah, enjoying a 4th of July celebration. One day before, 2 6.9 earthquakes hit Ridgecrest, California. I wasn't monitoring those at those times to find out exactly how strong they were. Probably a lot stronger than 6.9. To make matters worse, USGS made one of those quakes disappear. There were 2 separate quakes, 2 separate locations. They made one of them disappear. Then, the other quake they downgraded to a 6.4. A half magnitude downgrade. Now, if that quake was stronger than that, they downgraded it a full magnitude at least. Then the next day, we had a 7.1, they said. Now, we have information that says that that earthquake was probably an 8.0, 8.1 earthquake in Ridgecrest. Very much a major quake. Judging by the damage, the people that felt that quake, people felt all over from Ridgecrest down to San Diego. They felt it out in Las Vegas. Northern California felt it. That was a big quake. And really an 8.0, not a 7.1. You can't trust those people from USGS. And again, it's not the everyday people. It's management. Management needs a red ticket to see you later. Okay? I'm just telling you this, guys. You need to know it. Rob says, I believe it was North Ridge Rec Park. On receipt, yes, I believe you're right. I believe you're right, Rob. It probably was on receipt. I remember that. It probably was. But what I'm talking about, guys, every one of us needs to know what happened. Every one of us needs to have the chance to prepare for it. And I'm not above telling you the stories why. I'm not above showing you what is going on now. Because we may save your life. We may save your life. Over here at Mount Rainier. In a few minutes I'm going to show you the seismograms from Mount Rainier, Mount St. Helens, Mount Hood, and further. But here, over here on the northwest side of Mount Rainier, they say a 0.2 microquake hit. Over here on the southwest side, they say this was a 0.9 microquake, 1.0 tremor. Anytime there's 0.9, I magnify it up, because it usually is. Now remember these two tremors, microquakes, because I'm going to show you some seismograms that are going to blow you away. It's not just 2 microquakes. Dozens of microquakes, tremors, and earthquakes have hit Mount Rainier today. Okay? Further south and west, this is Mineral, Washington, 6 miles south-southwest of Mineral. They're saying this is a 0.6 as well. Really? No kidding. No joke. Mount St. Helens, guys. Look at this. I just love this. Yes, it looks like these earthquakes are on the flank, but they're deep. They're deep. This, they say, is a minus 0.3 because they say it's above sea level. Well, guys, guess what? This is 1.5 miles deep. It's not above sea level. The marker here, the marker says it was above sea level, but guess what? This is a semi-deep quake. 1.5 miles deep. 1.5 miles deep. And that's really nothing. That's a shallow quake. Right next to it, they say this is a 0.1. microquake. They say this is 21 miles north-northeast of Amboy, Washington. Folks, where is it? You can see where it is. It's not 21 miles north-northeast of Amboy, Washington. It's at Mount St. Helens. It's at the volcano. And on the southern side of that volcano, that earthquake was 3.9 miles deep. 4 miles deep. Really? This other quake that's south of Mount St. Helens, they say this is a 0.4 microquake. 22 miles northeast of Amboy. No, it's at Mount St. Helens. Mount St. Helens volcano. And again, remember this information when I show you the seismogram. I think you'll be blown away. Southwest of St. Helens. This is Deer Island, Oregon, a 1.2. They're not showing anything at Mount Hood. What a bunch of malarkey. I'm going to show you seismograms here at Mount Hood that'll blow you away. It's going to prove them major liars. Major liars. Then here we see a diamond. We see a diamond. Okay? This diamond says it was a 1.3 explosion. 2 miles southwest of Tualatin, Oregon. Tualatin, Oregon. Tualatin, Oregon. Guess what? Look where this is at. This is a 1.3 tremor. Nobody felt it. This is 0.1 miles deep. 1/10 of a mile deep. Okay? I'm zooming in here. There's a bunch of trees here. There are farms here. Farmhouses here. It wasn't an explosion. I don't think it was a explosion at all. I think it was deeper than that as well. Okay? That was not an explosion. Sorry. Sorry, USGS. You're wrong again. Okay? Now, you don't see anything else except this offshore here. That 1.7 Cape Muris, Oregon. Until we get further south, okay? They say this is 11 miles north of Unity, Oregon. A 0.7 tremor. A 0.7 tremor. Well, that's good. It's a tremor. It's in a wooded area here. Okay? It's near a town. Right there. 11 miles north of Unity, Oregon. This isn't 11 miles. Sorry. That's not 11 miles. And that is the nearest town. Did they, by chance, decide to make it further away from that town? Like way up here or something? Maybe it was way up here. I don't know why USGS does that. I could show you all over Alaska how they've done it here today. It's like they do it purposely. Purposely. Now I showed you that earthquake down here near Petrolia, California. This whole area from Petrolia north is called the Cascadia subduction zone region because it's so near the Cascadia subduction zone fault line. Okay? Let me drop this map. Okay? Well, I don't even have to do that because USGS just dropped me, and that's okay. Okay? I was going to show you a few earthquakes. Nothing real major happened today around the world. We had one 5.1, I think, and that's all. All the other earthquakes that we've had were basically moderate earthquakes. Moderate earthquakes, 4.0 to 4.9 earthquakes. That's it. That's it. As for seismograms, okay, I'm taking you up now to Mount Baker. Mount Baker is just south of the Canadian border in Washington State. Okay, Mount Baker has a lot of seismographs, machines. These volcanoes here, except for Glacier Peak, have a lot of machines, seismographs around the mountain. Why? They want to get accurate readings of any seismic activity around the volcanoes. Mount Baker has been steaming for a very, very long time. A long, long time. I've got pictures of it steaming from 4 years ago. This seismogram here is from the ski resort called Shuksan. S-H-U-K-S-A-N. A ski resort on Mount Baker. Now, the main seismogram that you can try to find is MBW. That is the code for Mount Baker, the main seismogram from Mount Baker. It's been down for a long time. All it shows is no picture available, no photo available, because they've taken it down for a long time now. It's not been available to anybody. Okay, I'm going to expand this so you can see the full magnitude of what we're seeing here on this seismogram. These wavy lines here are called very low frequency lines, VLF. I have a couple seismograms that I'm going to show you that have these VLF wave lines. Why? Why do they have VLF lines? These VLF lines, guys, shows the amount of activity, magma, that's coming into the volcano. These VLF lines here show a great deal of magma coming into the volcano. Magma produces VLF waves. That's what we're seeing here. Okay, the top of this seismogram was yesterday at 5 p.m. Yesterday at 5 p.m. Look at the amount of magma that was coming into this volcano yesterday afternoon. That's huge. But folks, it doesn't stop. It slowed down a little bit. It slowed down a bit during the night. That's what typically happens with all of the volcanoes and seismic activity around the world. It slows down at night most of the time. Sometimes we get hit with a major eruption or a major earthquake in the middle of the night. That has happened. But by and all, it slows down during the night. And then it increases once the sun comes up. And that's what you see here. Yesterday afternoon, there was a lot of magma surging into this volcano. And I can tell you guys, when you have these surges of magma coming in under pressure, you have earthquakes. Earthquakes galore. Because the magma coming into the volcano tears apart the rock coming in. Okay? It tears apart the rock coming in. And that causes earth movement, doesn't it? That's why we get tremors and earthquakes at these volcanoes, because of magma coming in to the magma chamber. Like I said, this is a ski resort at Mount Baker. All the other seismograms that I searched to today, and I've probably gone through between Washington and Oregon today and California, I've looked at probably 400 to 500 seismograms from early this morning on. Okay? That was that. There's more, guys. There's more. That was Mount Baker. Okay, I'm going to go down just for kicks and giggles. I checked out Glacier Peak today. That seismograph is down. There's only one seismograph at Glacier Peak. They're supposed to be putting up 5 more, but they have not done so. Glacier Peak, we don't know what's going on. I would say probably the same thing as Mount Adams. Steaming, Not a great deal of seismic energy. Yes, we've had 2s and 3s at Glacier Peak recently, but other than that, very little. I think some of it USGS is hiding. We've proven that over the years. Okay? So I'm going to jump down now, not to Glacier Peak, but to Mount Rainier. I want to show you what we've seen happen at Mount Rainier. Okay? Over on the northwest side of Mount Rainier, we have the Observer. Okay? That was the name, or this is the name that they've called this seismograph. Observer. Look what we see. Up at the top, this seismograph started recording information at 2 p.m. yesterday afternoon. We have not really thick lines, but thicker than normal here. Okay? We have thick lines here. They get thinner and get thicker again. That shows incoming magma. Each of these lines are 15 minutes long. Each of these lines is showing 15 minutes of magma activity. When you have a vertical line going through any one of these horizontal lines, those are either tremors or earthquakes. If it's a vertical line with no dot in it, that is steam exiting the magma. How is that possible? 6 to 7% of all magma is water. 6 to 7% of all magma is water. When that magma is able to release the water from it in the form of steam, it's only because there's a way out for that steam to be released, i.e. through the summit. It could be through another part of the volcano, where it's able to release this little bit of steam. We've seen that happen. Fumaroles that are around the volcano can help release some of that steam. Okay? If it comes from the summit. The reason it comes from the summit, let me reduce the size of this so I can show you pretty graphically what happens. When the steam is being released, we have that lava plug at the top of the volcano. After the last eruption, there was lava at the top of the volcano, right? Red hot molten lava. It cooled down. As that lava cooled, it hardened into a rock. Okay? Hardened into a great big huge lava rock. There are different kinds of lava rocks, so it could be anything. Every volcano is different, depending on the magma that's in that volcano. Anyway, what is going on? We have a lot of magma coming up and hitting that plug at the volcano, right? When all that pressure keeps hitting that plug, what happens? The rock shatters? Yes, that can happen. But before it shatters, it develops little holes in it from the constant pounding and pressure of that lava or magma down beneath the rock hitting it. All that magma hitting it causes pressure cracking that rock, cracking that plug in the volcano. And when that happens, that plug is got holes in it, doesn't it? Yeah. It releases the steam from the volcano just like this. Okay? It's very hot steam. Hundreds of degrees hot, Fahrenheit or Celsius, it doesn't matter. It's very hot steam. And those holes that were in that rock get even larger as that steam is being released. It's a simple physics question here. When heated water comes through those holes in the form of steam, it enlarges the holes. The holes get larger. And at some point, when the magma is coming up and hitting that rock and continues hitting it, those holes get larger, and at some point that rock shatters. That rock shatters. Then we have an eruption from the summit or through the side flank of the volcano. We saw that last time at Mount St. Helens. It blew out the top and the side of the volcano. Okay? But here at Mount Rainier, look at all these tremors here. Again, this is from the northwest side of Mount Rainier. You're seeing tremors, right? Absolutely. Absolutely. Now, what you also need to know is this seismogram is not what it should be. Okay? They've reduced the amount of signal coming into the seismograph, so it's only recording what is allowed to show. Some of these vertical lines could be larger. It could be larger. And sometimes we're able to prove that fact. And I may have a seismogram or two that will show you how strong the signal was at the seismograph, showing you how disturbed these people are, because they don't want anybody to see exactly what's going on. These longer lines here, if they were taken as they are right now, maybe a 2.0 earthquake. 2.0 minor earthquake is nothing. Very rarely would it even be felt, depending on how close to the surface it was. That's number one. The strength of the signal, the strength of the earth movement. Okay? So it could be larger than this. We have at least a couple of those. The rest of the signals here on this particular seismograph are just low, just tremors. Okay? So this seismogram doesn't show us a lot, does it? But I want to show it to you as a comparison to other seismograms. Okay? I have basically 3 seismograms I use here at Mount Rainier. One of them, the most popular, is Rainier Emerald Ridge. They've taken that down too. So we no longer have seismograms from Rainier Emerald Ridge. Wonderful thing. They make stuff just disappear. Okay? This, folks, is Camp Muir. Camp Muir is over on the western side, the southern side of the volcano. Southern side of the volcano. Again, this seismogram is recording information, this time starting at 9 p.m. 2100 hours on the top line. You see 2130 there at the top. So the top line would be 2100, which is 9 p.m. You see tremors off the top, right from the very beginning. Then you see an earthquake here. This earthquake happened at 2:45 a.m. in the morning. Now that's over on the left-hand side. The 2:45 mark is on the left-hand side. So this is about 2:51 a.m. this morning. 2:51, 2:52 a.m. this morning. Okay, this was a larger quake. Just judging by the length of this vertical line here, this probably was a 2.3 earthquake at least. At least. Okay? It could have been a larger earthquake. But here you see tremors all over here. You see magma coming into the volcano. Here you have an earthquake. They didn't show this earthquake on the USGS map, did they? Not at all. Rarely do they ever show that. Heaven forbid they tell us the truth. You see a lot of magma coming into this volcano, don't you? A lot. A lot. If you see a vertical line without a dot in the middle of it, that is steam being released by the volcano. By the volcano. The rest of these are all tremors here. Look at that. all the rest of the day. And all these times are Pacific times, in the Pacific time zone. Okay? So that is Camp Muir. Let's go over and show you one more seismogram here at Mount Rainier. Okay? I just love this. Okay, I'm going to show you Camp Sherman. Camp Sherman is on the north side of Mount Rainier. That's where this seismograph is located. Now, look at what we're showing you here. Again, up here at the top, it says 21:15. This is 9:15 last night. Look at all the tremors here. You also see some long vertical lines here. Guess what? Earthquakes. If they don't have a dot in the middle of them, it's just gas vapor being released, water. Okay? Oh my gosh, we do have a magma churn signal. Remember me saying that there was a signal that's generated when hot magma, very hot, heated magma comes into the volcano? It's called a magma churn signal. It's that sideways rectangle you see here. Now, for kicks and giggles, I'm going to enlarge this a little bit so you can truly see just what we're seeing here. Okay, that rectangle should cover at least 23 to 24 lines if it was full power at the seismograph. This shows 1, 2, 3, 4, 5, 6, 7 lines. 7 lines high. Okay? Folks, that's less than 1/3. That is less than 1/3, about 26% of real world. That's what we're being allowed to see. Only 26% of real world. So these vertical lines, multiply them times 3, and you actually get how strong these earthquakes were. Out to the right of that magma churn signal, those other vertical lines to the right are steam. Those are steam signatures. Steam coming from the volcano. And Mount Rainier, Mount St. Helens, Mount Hood, Sisters Volcano, and others, they have steam pouring from the summit of the volcano. I should say in the realm of Sisters, it's 3 separate distinct volcanoes. Okay? But steam pours out from outside through the summit of these volcanoes. And sometimes they pour out other places, other vents. Okay? But you see earthquakes here, and it looks like maybe a 2.0. Multiply it times 3. You probably actually have a 3.5 magnitude earthquake. A 3.5 magnitude earthquake. There's a lot of them here. There's a ton of tremors. There are earthquakes here. And no, remember when I showed you the map, the USGS map? It didn't show any earthquakes. It showed some minor microquakes. There's a lot of microquakes, but there's just as many tremors and earthquakes as well. And they did not show them to us. Heaven forbid that we know the truth of what's going on. Okay? Now, because of time, it's already 8:45 Eastern Time. I'm not going to show you everything that I have, but I am going to show you Mount St. Helens, I'm going to show you Mount Hood, and probably Sisters Volcano, or volcanoes, excuse me. I may even show you Crater Lake, because there's a ton of atmosphere events happening at Crater Lake today. Crater Lake is down in south central Oregon. Let's go over to Mount St. Helens. Okay? I'm going to quickly show you just one seismogram for Mount St. Helens today. This is at the source of Smith Creek. There's a seismograph that's name is at the source of Smith Creek. Okay? Yes, there's a creek there. What are we seeing here? By the way, the blue seismograms I've been showing you come from the USGS. And they tell us that they get their information from the Pacific Northwest Seismic Network, which is the red ones that we show you. Okay? But they don't always jive. What we would show you on USGS may not be the same things that are on the seismograms from PNSN, the Pacific Northwest Seismic Network. In this case, we could not get a good read on what was happening at Mount St. Helens. Most of it because they have screwed around with the seismograph. This shows real good reality, what exactly is going on at Mount St. Helens. Look at that activity. The top of this seismogram starts at 5 p.m. yesterday. Tremors all over the place. Yes, I believe we may have had a 1.2 earthquake, 1.2 tremor, 1.5 tremor. However, look what happened today. Look what happened today, early this morning. Early this morning. Look at these earthquakes. Yes, at about, let me enlarge this so I can see the time on this. This happened at just after 8 a.m. on that black line. Look what's going on. Look what's going on. What are we seeing? We're seeing earthquake after earthquake, tremor after tremor. Folks, that is a huge amount of magma coming into the magma chamber, and you're seeing earthquakes and tremors hitting because it's fracturing the rock. The magma is fracturing the rock coming into the volcano. That's why you see the number of earthquakes and tremors all together right here on each individual line. Going down there, you see tiny lines here. Those are tremors. Each individual horizontal line has its own magma. Okay? Is recording magma coming into the volcano at that particular time. Now, I jumped down to that big earthquake that happened this afternoon. Okay? Look at this earthquake. Actually, it wasn't even this afternoon. It was this morning, just after 10:30 a.m. That blue line is 10:30 a.m. So over here, it's 1, 2, 3. It's 10:04 a.m. when this earthquake hit. Look how long that these blue lines are going up and down. Okay? This tells me that this earthquake was at least a 4.5 earthquake. At least a 4.5 earthquake. The top of this signal here, you see all those lines going up and down here? They're long lines, but they've topped off the top of this signal. They're hiding information. They do not want everyone to know how strong this earthquake is. This was at Mount St. Helens. This was at Mount St. Helens. 4.5 earthquake. And no, USGS does not show a 4.5 earthquake here. They're not. Heaven forbid they tell us the truth. You can see other earthquakes here as well. This one on this lower black line in the center left. Folks, that is at least a 3.0 earthquake, if not a 3.4. And you can see these other lesser quakes here. Okay? So you can see what I'm talking about. Now, look what time it was when the seismograph quit recording information. Just after 2:15. It says 1400 on the left. That is that black line just above that. 1400 would be black. The next one is red here. It says blue. It's all screwed up. That blue line's beneath this. But red is always a 15-minute line. So after, I think it's probably after 12:30, excuse me, not 12:30, 14:30, which is 2:30, it stopped recording. Actually, stopped recording about 2:49 p.m. Because we have no documentation from 1500 on. They shut this down. No, I did not pull this information until 4 o'clock. They shut off the seismograph. I ask the same question every day. Why do they shut off these seismographs? Why don't they let the seismographs speak what happened? Why do they reduce the signal? Because they don't want anybody to know what exactly happened. That's Mount St. Helens, guys. Mount St. Helens. One more there, just to show you what happened. Okay? This is Mount St. Helens, and this is what they call September lobe. September lobe is a multi-channel seismograph. It sits on top of the summit of the volcano at Mount St. Helens. It's got spindly legs like a spider. And they usually commonly refer to this seismograph the spider seismograph. The correct name is September lobe. On this particular channel, guys, on this particular channel, you are seeing the magma coming into the magma chamber at Mount St. Helens. Look at this. Late or early yesterday afternoon, it was quiet. Okay? It was quiet. And it got quiet until 8 p.m. And after 8 p.m., the magma surged into Mount St. Helens. What did we see on that other seismograph? The same information, except they turned down the ability for us to ascertain what exactly happened. That's why I like coming over to the VLF frequency. It's HHN. Okay? In this case, it says SEP BDF CC 01. This particular seismograph and this channel is that signature there. And we're seeing a lot of magma here coming into this volcano under pressure. It's no wonder we had earthquakes last night. Look at what happened here. But look what happened after that. They turned off the seismograph. There's no line here showing any activity. Magma does not stop like that. Magma is always coming into the volcanic chamber. There's always some kind of activity. It does not stop like they're showing it here. Okay? So we know for a fact what they're doing here. They're playing games. I showed you tremors and earthquakes on the seismograph. With that much that much data that we have right here, it would cause tremors and earthquakes. All you saw on the seismograph were just tremors. Just tremors. All you saw on the USGS map, tremors. Again, they're not willing to show us exactly what happened. The other seismograms are all foobarred, or I'd show them to you. They're all turned way down. Some of them are not even reality. They're garbage. Total garbage. Let's go here and show you Mount Hood. The first thing I want to show you is this seismogram here. On the southern side of Mount Hood, there are two seismographs. One up higher at a ski resort. It's called Palmer Lift. Palmer Lift. It's a ski resort lift. And this is higher on the mountain, about halfway up the mountain, on the south side. Look what happened last night. Up at the top, Again, just after 5 p.m. We had a lot of tremors, huh? Oh yeah, maybe even some 2.0 earthquakes. That's a lot of information there. They've turned this seismograph down, so it's not reporting. Look what happened during the night. Again, all you see is a couple tremors. It may have been larger than that had they left the seismograph alone. The magma coming into this volcano created that tremor because there was so much magma coming in and it was hitting rocks inside the volcano that's causing earth movement, a tremor and or an earthquake. Look what happened later. This, I think, is what actually happened all night and all day today. Look at this information here. Folks, these are tremors and earthquakes. Okay? They're actually letting the seismograph tell us a story here for hours on end. Okay? Hours on end. What happened here? Starting at 0600 until 14:49 p.m. 2:49 p.m. 6 to 2:49. Okay? That's 8.5 hours. 8 hours and 45 minutes worth of activity here. You can see it. Yes, you can see some earthquakes here as well. This is on the southern side of Mount Hood. Let me show you another. This is Timberline at Mount Hood. This is the government camp seismograph. This is on the lower south side of Mount Hood, northern Oregon. Okay? Again, look what we're seeing here at the top. Okay? If I'm not mistaken, this seismograph begins showing information at 2100 again, 9 p.m. last night. The lines are fairly thick, so we see a lot of magma coming into the magma chamber. And you see some tremors here. Vertical lines on each of those lines. Those are tremors caused by rock fracturing of the inside the volcano. Okay? And then they turn it way down. Okay? You don't get all that kind of activity and then all of a sudden it stops. They turn down the seismograph nearly off. And occasionally we see something happen because there's so much going on inside the volcano, it's forcing the seismograph to record it. Okay? Now, this signature here in dark blue on the right hand side. Okay? This happened after 4 a.m. this morning. About 4:10 a.m. You see the thinner line getting larger here. That's typical of what we would see. Okay, that's called magma pulse signal. Magma P-U-L-S-E signal. Okay, thinner lines getting thicker and then get thinner again. That's what we see here. You see the vertical lines? Those are tremors caused by the magma. Okay, you can see it here on the lighter blue line, or magma signal here. Okay, a lot more magma causing tremors here, causing tremors throughout that time here. And then, all of a sudden, out of nowhere, they turn the signal down. They turn the signal down for another hour. And then, after that, all we see is it's sporadic. Magma doesn't do that. What happens here? Again, this is at Mount Hood. This is at Mount Hood. You're seeing magma coming into the magma chamber here at Mount Hood. This is timberline on the southern side, the southern lower side of Mount Hood. That, folks, is a lot of magma. Yes, the seismograph has been turned way down, or those lines would probably fill up the paper, where you wouldn't even see white in the paper. Okay? Again, the agency doesn't want us to know the truth of what's going on. If anything happens, guys, it's probably going to be Glacier Peak. Yes, it could be Mount Baker. It could be Glacier Peak. It could be Mount Rainier. It could be Mount St. Helens blowing up again. It could also be Mount Hood. It could be Sisters Volcano. It could be Bachelor. I can't even show you Mount Bachelor because they've turned it off. They turned it off. I showed you, I believe it was last week, that all they show is a line. The same thin line all the way down the entire seismogram. It doesn't happen like that. Just these seismograms alone, you see that nature doesn't do that. You're not just going to have a solid horizontal line. That's not going to happen. That means they've either turned it off or they're not allowing the seismograph to do its job. Not reporting anything. Now, I'm going to drop down to Sisters Volcano because I want you to see it. And I may show you one from Crater Lake as well. There's a lot going on at Newberry Volcano as well. Newberry is south of Sisters. But this is Sisters. Why am I showing you this? This is one I picked out to show you. Sisters Volcano is actually 3 different volcanoes. Sisters Central, Sisters North, and Sisters South. Okay? When we had this kind of activity months ago, even possibly late last year, we didn't see just tiny tremors here. What we did see is stuff like this, activity just like this. This shows a lot of magma coming into the volcanoes at Sisters Volcano. This isn't just one volcano, it's 3. And unfortunately, we don't know exactly what is going on because this seismograph is only monitoring the volcanoes, plural. But you can see a lot of activity here. That is a lot of magma creating earthquakes coming into Sisters Volcano. The last time it did that, USGS issued a they issued a yellow eruption warning, meaning it could erupt at any time. Fortunately, just like Mount Hood did 2 years ago, it stopped. And there's been no more eruptive activity like this happening at Sisters. Okay? But it's getting close. One more. Down in south central Oregon, there's a volcano called Crater Lake. Now, I'm hesitant to show you just one seismogram. I may show you 2. Over on the northeast side of Crater Lake is a volcano, a tall volcano. And the top of the volcano has walls going up, the rim of the volcano, just like we've seen at Kilauea in Hawaii. This stratovolcano has walls upwards around the volcano. That's because the volcano caldera is lower. The volcano, the last time it erupted, left a huge sheet of lava that hardened, and it's further down inside the volcano. Well, guess what? Groundwater and rain and snow has accumulated in this lake, and now it's a very deep lake. Okay? Guess what? It's busy. For several months earlier this year, they turned the seismograph off. This is over on the northeast side of Crater Lake. It's called Cleetwood Cove. Crater Lake, Cleetwood Cove. This seismograph is reporting a lot of activity. Look at this. Again, this seismograph shows activity after 10 p.m. last night. Look at this. That's a lot of earthquakes. That's a lot of earthquakes. And then, guess what? They turned it basically off. It's hardly reporting anything after that until later today. Okay? It's just barely showing magma here at 12:15, 12:45. Just barely showing any magma coming into the magma chamber. Bullcrap. You saw the activity last night. That activity continued. No one can tell me that there's no activity all these hours, and then there's very slight magma coming into the magma chamber, and then all heck breaks loose here. Look at that. Look at all the tremors and earthquakes, and these are, they're light tremors, but the longer lines are earthquakes. The lines that are about an inch long, those are 2.0, 2.2 earthquakes, minor earthquakes. The longer lines, probably close to 3.0. Probably close to 3.0. Okay? And yet, they did not post anything on the USGS map showing any kind of activity here at Crater Lake or the surrounding area. They did not post anything on the USGS map. They never will. They want everybody to believe that nothing is happening at these volcanoes. That's why we show what's going on. Okay? Now, in the past couple weeks, we talked a lot about Cascadia, the megathrust earthquake that's going to happen. 2.5 years ago, we had every reason to believe, because of the activity at the volcanoes and out in the ocean, showing earthquakes out in the ocean. There's a seamount off the coast of Washington. It's a volcano. When you hear the word seamount, that's a volcano. This particular one I'm talking about is off of Washington. We have undersea mounts all over the world. All over the world. That undersea mount off the coast of Washington is erupting underwater. Underwater. 2 years ago, USGS, in combination with the University of Oregon in Portland, got a hold of some money. They put seismographs on the ocean floor off the coast of Oregon. 52 of them. They put them there 2 years ago. They have not released any information whatsoever. None. Occasionally we see sporadic earthquakes off the coast of Washington and Oregon, but there's a lot more going on that they're not telling us. Okay? The Cascadia megathrust earthquake will happen. We don't know when. I don't want to worry anybody. I don't want to cause any stress or heartache for anybody. It's going to happen. Now, as my friend Don, who's one of our mods, a very dear friend of mine, known him for a lot of years, he's put up information about getting prepared. Preparedness information. Please heed that. You need to have an emergency plan, number one. And not just for an earthquake. Find out from your local emergency management office, wherever you live. Contact them. If they don't have an emergency management office, the fire chief is usually the one that handles emergency information like an emergency manager would. The fire chief. Contact him. Ask him what kind of emergencies that happen or could happen in your local area. And then you need to prepare for those emergencies. Write a plan covering any kind of emergency that could happen, including shootings. We have many shootings throughout any day of the week here in the United States, and there are other places that also have them. Italy, France, Germany, Austria, Switzerland, Croatia, Romania. I hear about them. What happens if you are in or near an area where some suspect is wildly firing at people? What are you going to do? Prepare for every kind of emergency that could happen to make sure you get through it and come out the other side. Now, it might take a little while to mitigate the circumstances. In other words, take care of the problems that you have after a major incident, but at least you made it. You can work on repairing the damage after the fact, but you made it through the emergency. That is the key here. You and your family made it out alive, and you can rejoice in that fact. But that is the truth, guys. Make sure you write a plan covering everything, covering what you have in the way of food. Make sure you have a way out of an emergency area, a fire or a flood. You may have to evacuate. Do it. Make sure your car is full of gas, number one. Number two, make sure it's in operational condition, that it will get you out of Dodge during an emergency. Okay? Also, you may want to find a place or several places that you could go if you have to bug out, meaning evacuation. Get several places, not just one, but several places. Why? Well, if your road's closed, what are you going to do? If your road is closed, what are you going to do? You're not going to be able to stay there, are you? Because there's an evacuation process. If the road's closed, where are you going? That is a common question. Where are you going to go? Make sure your car is in good condition. Make sure you are prepared to deal with it. Make sure that you have at least 3 ways out of Dodge. One way may be having a bunch of roadblocks. Maybe one road, other road, might not be passable because of what happened during an emergency. Or it might have a ton of people. Traffic jams. Make sure you can use surface streets and roads. Stay off of main arteries. Stay off and away from main arteries where there could be a roadblock. Highways, for example, stay off them. Take surface streets. Then have 3 separate places that you could go. Why 3? 1 or 2 of them might be closed. One of them might be full up and can't take any more people. The best thing for you to do during your planning is to contact 3 separate places. Go out there yourselves and scope out 3 separate places you could go during an emergency situation. You may have to camp or be in your car, but at least it might be a safe place to be at. 3 separate locations, and talk to the people out there. Talk to the people that run the mobile camp, or whatever it's going to be called. It could be a forest area. It could be a state park. Go there and talk to the people that run it to make sure you might have a place to stay during an emergency. And they'll give you a good idea. They work there. Okay? Make sure you have food, water, tenting material, sleeping bags, warm clothes, possibly jackets. We're still in the summertime time period right now. But starting in September in a lot of areas of here in here in the U.S. or Canada, or even in England or Scotland or Ireland, it's going to get cold. It'll be wet and cold, possibly snow and ice. Sweden, Norway, Denmark, Croatia, Romania, Slovenia, wherever you are, make sure you have what you need to survive. Food and water and shelter. Okay, I can't stress that enough. Make an emergency plan, have food, water, and shelter. Put all that kind of stuff in your plan and address it for every member of your family. It's not just you that's surviving. Every member of your family should be included in this. This is absolutely imperative. Okay? What other channel talks about everything that's going on? And it could also be political. Your emergency might include politics, people trying to seize power and become tyrants. We see that happening literally all over the world, and it's getting worse by the day. Okay? Militias starting up. It could be next door neighbors. It could be your own family members. Family against family. Neighborhood against neighborhood. It can be roving gangs stealing what you have. You have to have some way to protect what you got. Think about everything. All this stuff should be in your plan, and you should be making these plans immediately, if not sooner. Immediately, if not sooner. Now, guys, I know I've said a lot today. I've talked a lot. It's now 9:18 p.m. Now, I've talked about this scripture once before. I wanted to leave you with a thought. I've talked about this scripture before, and I still believe it. It happens. It's not just talking about what Paul the Apostle wrote to Timothy, his friend. It's talking to us today. The scriptures can talk to us who are living right now. It tells us in verse 12. Yea, this is 1 Timothy chapter 3, verse 12, starting with verse 12. Yea, all that will live godly in Jesus Christ shall suffer persecution. But evil men and seducers shall wax worse and worse, deceiving and being deceived. But continue thou in the things which thou hast learned, and hast been assured of, knowing of whom thou hast learned them from. Verse 15. And that from a child thou hast known the Holy Scriptures, which are able to make the wise unto salvation, through faith which is in Christ Jesus. Verse 16. All Scripture is given by inspiration of God, and is profitable for doctrine, for reproof, for correction, and for instruction in righteousness. Isn't that a hint about what we see going on? What we know we should be doing and preparing for? Guys, I love each and every one of you, like I told you earlier. This is not the first rodeo, nor will be the last. You need to prepare, and you need to do it now. Yes, we are having earthquakes. Some places a lot worse than others. And then we have nearly a major earthquake, a 6.8 in Spain, and only one agency reporting it. The other agencies decided it was not wise for them to do so. I would love to know the reasoning. It doesn't matter. We need to be prepared ourselves, because we may not find out information until it's too late. Prepare now. Prepare now. Folks, if anything else happens tonight, we'll be back here telling you about it as soon as the information becomes available. We'll be back. We'll be back tomorrow evening after 6 p.m. with more Emergency Management Associates, another episode of this program. Please invite your friends, your neighbors, your loved ones, your family and extended family, the people you work with, and even the people you associate with on social media. Everybody needs to know about this channel. It's absolutely necessary. We want to grow this channel fast. We had, like I said, 25,000 subscribers on the other one until a hacker took us down. I honestly believe it was Google, YouTube, but I can't prove that. They said it was a hacker. But folks, we want to grow this back. We need to have touch with people to warn them what's going on, to help everybody recover and live through whatever happens. God bless you guys. God bless you, and please know that we love you. Have a good night, folks. We will see you on the other side. As Walter Cronkite would say, and that's the way it is. Monday, July 31st, the last day of the month, 2023. Have a good night, folks. God bless. See you soon. God be with you till we meet again.